All right, maybe I can get it right this time. Let's see. So we're starting video 1.4. This is part B. If you haven't yet watched part A, you should go back and do that, or this is not going to make much sense to you. All right, we're going to pick up right where we left off, which is we were looking at this. So as you can see, our moving man is currently standing over here by the brick wall, which means his position is -10. I got it set up so his velocity is 0.5. So before I do this, pause the video and ask yourself what the position time graph is going to look like. All right, I am now assuming that you've paused the video and thought about this. What's going to happen here is our position is going to start at -10, and then every second his position is going to increase by ½ a meter. So after 2 seconds, it'll have gone 1 meter, and it'll be at -9, and so on. After 10 seconds, he will have gone 5 meters, right? Because he goes ½ a meter every second. So in 10 seconds, he'll go 5 meters. So I believe that our line should pass through this point, and it'll take him 20 seconds to go 10 meters, which means after 20 seconds, his position should be 0. That is my prediction. Let's click go and see what happens. So his position's increasing. We're at 4 seconds, he's at -8. 8 seconds, he's at -6. Boom. 10 seconds, he was at -5. His position is increasing very, very slowly. Kaboom. There we go. All right, so let's label what we just looked at here. This is a position initially of -10 meters and a velocity of 0.5 meters per second. Okay? So what I've done is I've saved this line now, and I have returned our moving man back to his position of -10, and now I set his velocity to be 1 meter per second. So what this means is this time his position is going to increase by 1 meter every second. So if he's going 1 meter every second, that means that he's going to be moving faster. So I would like you to once again pause the video and ask yourself, what's the graph going to look like this time? So I'm going to assume that you've now paused the video and have thought about this. Here's my prediction. I believe that the graph is going to start at a position of -10, because that's where he's at right now. This time he's going to move 1 meter every second. So that means if he's going 1 meter every second, in 10 seconds, he'll go 10 meters. So my graph should be here after 10 seconds, which means after 20 seconds, he should go another 10 meters, and it should get me to up here. So I think that my graph is going to go through those 2 green dots that I just drew. Let's do it and see what happens. Here we go. Kaboom. Move, moving man. So the graph looks similar to the last one, but it seems to be going up quicker. The word for that being the graph is steeper, right? So while this is going, let's write down what's going on here. So this time, oops, I guess I should click stop, shouldn't I? Boom. All right, so this time what happened was our initial position was once again -10 meters a second. Same starting position, but this time the velocity was 1 meter per second. Okay, so I'm going to save it all again. Okay, so let's do this again. This time, I've once again brought him back to the same starting position, so our graph should start down here again, but now his velocity is a crazy 2 meters per second. So pause it and predict what the graph is going to look like. All right, let's see if we were right. Here we go. Go. Huh. All right. Boom, he hits the wall. Here's your sound effect. All right, so this time, here we go. Whoops. Our initial position is -10 meters. Our velocity is 2 meters per second. Huh. So let's see. This bottom one is 0.5 meters a second. This one here is a little bit steeper. That's 1 meter per second. I'm pointing and you can't see what I'm pointing at. Sorry. Let's do that again. This bottom one, the velocity is 0.5 meters a second. The middle one is 1 meter a second. This top one is 2 meters a second. It looks like the faster you go, the steeper the line is, which should make sense if you think about it, because what's happening is in a certain amount of time, your position is going to change by a certain amount. And the faster you're going, the more the position changes by. All right? So let's do this one last time. Let's do it at 5 meters a second and see what happens. All right? And stupid. All right, before I go any further here, I just discovered a small mistake that I had. I labeled my position here as meters per second. That's not right. That position should be in meters, right? Because it's not how fast, it's where he's at, and that's measured in meters. I apologize if that was confusing you. All right, so here we go. Last one. Let's see what happens if he goes 4 meters per second. The graph is super, super steep, isn't it? I paused it there in the middle because what I want you to understand is his position just changed, right? His position went from -10 to about 2. So it changed by 12 meters in a very small amount of time. Let's see. Very small amount of time. He went 12 meters at 4 meters per second. So that took him, oh look, about 3 seconds, right? So the idea is, in a small amount of time, we had a big change in position. Okay? So let's let him continue his motion until he hits the wall, bam, and then he stops. All right? It's probably also worth pointing out, I haven't talked about this at all yet, look at the velocity time graph. Okay? The velocity time graph has, look, the velocity is 4. For the first, what is that, 5 seconds, right? The velocity is 4 for the first 5 seconds until he hits the wall, and then the velocity drops down to 0 because now he's hit the wall. He's not moving anymore, right? So at this point, because our velocity is constant while he's moving, the velocity graph is pretty uninteresting, right? It's just showing you that the velocity is always, in this case, 4 meters a second. Okay? In the one before this, the velocity was constant. It was always 2 meters a second. In the first one, the velocity was always 0.5 meters per second. Okay? So what we have learned here is that the faster the object moves, the steeper the position time graph is. And really quick, last thing I'm going to do, and then I'm going to stop because I'm well over the time that I promised you guys I would keep these videos to. I'm going to set his starting position to +10, and I'm going to make his velocity -2 meters a second. I'm going to pause it. You think about what you need to do, or what the graph is going to look like. Okay, last one. So I got his velocity. Oh, sorry. I've got his position set at 10. His velocity set at -2. So right now his position's 10. He's going to go this way 2 meters every second. 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 So it looks like after 1, 2, 3, 4, sorry, let me keep pointing and you can't see it. After 1, 2, 3, 4, 5 seconds, his position should be 0. So his starting position is 10. After 5 seconds, we're predicting his position should be 0. All right, let's try it and see what happens. Oh, yeah, don't steal that song. I just copyrighted that. It'll be up on YouTube soon. Oh, it's on YouTube. Yeah. All right, there we go. And check it out. Velocity is negative, oops. Velocity is -2. The graph went down because the velocity is a negative number. The position is decreasing, so it slopes down. Notice after he stops moving, the position stays constant. Okay. And the last thing I'm going to say before I stop in just under 10 minutes is the link to this program is on my website right under the videos. Go play with it. It will help you understand this better. All right. Have a good day, weekend, whatever you got.